Hello, this video will discuss how Truda Environmental Solutions high-definition stream survey technique, also known as HDSS, will provide you with the data you need to get better results from your waterway project. This video uses actual footage from a project we did that involved the removal and restoration of Goodwin's Mill Dam on Big Canoe Creek, Alabama. Anyone involved with waterway projects knows they are highly complex and challenging in different ways. But when you break it down, many of these challenges can be alleviated with better data. So here are a few questions you should be asking yourself before you start on a new project. Question 1. Can I accurately predict and measure project impacts up and downstream from the immediate project site without having a detailed baseline condition of these areas? Question 2. Do I have enough data to know exactly where to prioritize my restoration efforts for maximum ecological lift? Question 3. Do I have enough data to ensure that my project methodology will have the greatest improvement for the lowest cost? Question 4. Do I have enough data to ensure a smooth permit application process? If you answered yes to all of these questions, congrats, you're in great shape. If you're not sure, then let us explain how a high-definition stream survey can get you to yes. A high-definition stream survey is the continuous collection of video and sensory data over multiple miles of waterway. What does this mean? We have cameras pointing to both the left and right stream banks recording bank and riparian condition, infrastructure, and point and non-point sources of pollution. Our forward camera records habitat types such as pool, riffle, run, large woody debris, and other requested information. Our underwater camera allows us to assess the stream bed for substrate type, embeddedness, aquatic vegetation, and other visible underwater features when conditions allow. Our water quality sensor records numerous water quality parameters at a 1-second interval. If turbidity and depth are not conducive to underwater video, our side-scan sonar will georeference numerous channel characteristics throughout an entire reach. In addition to longitudinal depth measurements recorded every second, we can collect cross-sectional bathymetric measurements at any requested location. We can use an acoustic Doppler current profiler to measure discharge for more detailed bathymetric projects. We can easily accommodate the growing demand for eDNA as well by collecting grab samples as frequently as needed. Most importantly, the latest GPS technology ties all of this information together at an exact time, location, and surface water elevation. This allows us to deliver extensive GIS data that can be used by itself or with other layers of GIS information. Depending on the size of stream or river, HDSS can be deployed using different platforms to rapidly record all of the data and video you need in a single survey. Documenting everything in the stream corridor allows the same HDSS data to be used for multiple permitting requirements, including FERC relicensing, Corps of Engineer permitting, MS4, and others. Completing a high-definition stream survey before a dam removal will document and record baseline conditions, which is required by the Corps of Engineers Nationwide Permit 27. In addition to documenting baseline conditions at the actual site of any construction, HDSS also collects upstream and downstream data to document any other issues that could be negatively affecting the stream. After construction has been completed, periodic follow-up HDSS will thoroughly and accurately document actual changes throughout the entire reach to help determine the success of the project. The Goodwin's Mill Dam removal is an example of how effective HDSS is in measuring post-construction results. Goodwin's Mill Dam was breached years ago but was continuously clogged by storm debris and sediment, creating a fish barrier that the U.S. Fish and Wildlife wanted to remove. The baseline HDSS documented pre-removal conditions in 2013. This step is critical because the video and accompanying data, which covered 3 continuous miles above and below the breached dam, will always be available as a reference for later comparisons. The second HDSS was completed in 2016, 3 years after the dam had been removed, with the exact location being shown in this video. In addition to thoroughly documenting the dam site, HDSS provides the ability to compare river video and data changes at every point along the river for the entire length of the survey. After it is collected, field data is fed into a database where it gets processed to fulfill the requirements of a project. Truda has developed HDSS video coding software that can quickly analyze and categorize numerous data parameters, all of which are linked to the exact GPS location where the data was collected. Georeferencing such large volumes of data reveals trends and information that would never be apparent using traditional site-based sampling methods. For this survey, bank condition and habitat types were mapped out and delivered for monitoring purposes. Bank condition is the most common parameter that HDSS users want to assess on their waterway. The first 4 out of 5 levels of bank conditions seen here are based on several different assessment protocols to enable fast and efficient classification. The left bank shown in this dashboard is an example of the worst score for bank condition. Normally, areas like this that are obviously contributing mass amounts of sediment to a stream are prioritized for restoration. But this location was only revealed after HDSS was conducted for a few miles up and downstream of the project site and brought to the attention of the U.S. Fish and Wildlife Service. The point here is that assessments limited to the immediate project site will not identify areas like this. Not addressing these problems will negatively impact and could even completely undermine the goals of a project. The following series of slides highlight how effective HDSS is at measuring project impacts over time. This slide shows changes to stream habitat before and after a dam removal. This slide shows changes to water depth. A clear advantage of HDSS is the ability to zoom into any area and compare still images or videos of the conditions for yourself. This slide shows a more detailed comparison of water depth at the actual dam removal site. This comparison shows the changes to embeddedness after the dam removal. You can see how much sedimentation has flushed from upstream areas in the 3 years following dam removal, some of which had started to accumulate downstream. Here is the comparison showing changes to right bank condition. This area highlighted shows increases to very poor bank condition that occurred in the 3 years between surveys. Here is the comparison for left bank condition. These slides give you a taste of how well HDSS can help you visualize the before and after impacts of a project, but they represent only a small portion of the data we collect in a standard survey. Importantly, HDSS captures change over time for virtually any parameter you might want to see. These include visual as well as non-visual parameters such as water quality, water quantity, temperature, and others. As we've already discussed, using HDSS data makes it easy to prioritize and locate areas of high bank erosion hazard, but the power of easy-to-understand images makes it useful for everyone. Here is a great example of this. Using our GPS track logs and video, we were able to measure a 6-meter channel migration that shows no sign of stopping. Using track logs from 2016 in white and 2013 in pink, we can see just how much the channel has migrated due to extremely high erosion rates. The largest migration was measured at 6 meters. The distance of channel migration multiplied by the length of failing bank and bank height will calculate an amount of actual sediment loss. In the 3 years between surveys, over 1,400 cubic meters of fertile farm soil had been eroded into the stream channel, causing multiple issues for resident fish and mussel species. In closing, HDSS is a better waterway assessment technique for the following reasons. We can collect more data using fewer people in a shorter amount of time compared to traditional assessment methods. This leads to lower costs. Continuous data is better than site-based data because there are no extrapolations and you are able to see everything. These and other factors combine to make HDSS a better data solution for your permitting, planning, and mitigation projects. Thank you. Again, we are Truda Environmental Solutions, developers of the high-definition stream survey, bringing you more data at a higher quality at a lower cost. Contact us at info@trudasolutions.com or visit our website at trudasolutions.com.